Hello, welcome for my presentation. My name is Ariel Soji. I am with the USDA Agricultural Research Service at Florence, South Carolina in the USA. I'm going to talk about acidification of manure using carbohydrates as acid precursors. Previous research has shown that acidification does not increase gas emissions. In fact, it can reduce ammonia emissions during manure handling and soil application. Acidification can also effectively reduce methane emissions from stored manure. Another benefit of acidification is to increase the fertilizer value of manure because it conserves nitrogen. Acidification can also impact other manure treatment processes, such as improving manure solid liquid separation, phosphorus extraction and recovery, composting, and biogas production. However, a significant barrier for adoption of acidification for manure is the cost of the commercial acid and the specialized equipment for handling concentrated acid. An alternative to commercial acid is the acidification of manure by adding a fermentable carbon source to produce organic acids. The fermentation process depends on the diverse microbial community present in the animal manure. The objective was to test carbohydrates to promote manure acidification as a more cost-effective alternative than commercial acids. We conducted bench experiments to evaluate acidifying manure and selectively strip phosphorus using glucose, sucrose, starch, and cellulose as acid precursors. The tests consisted of swine manure slurry treated with varying concentrations of each carbohydrate in the range of 12.5 to 100 grams per kilogram of manure. We incubated the manure carbohydrate mixture in the laboratory for up to 7 days, including one treatment control at laboratory temperature. This study included a quantification of volatile fatty acids and lactic acids during the fermentation process, but their data is not presented here. As an example of the acidifying effect of added carbohydrates to swine manure, a significant acidification occurred from pH 7.7 to about 5.3 when we used glucose or starch at an application rate of 50 grams per kilogram of manure. Within 5 days, we observed that the pH was reduced to about 5.3 units, and simultaneously we had an increase of soluble phosphorus up to 1500 milligrams per liter. From these results, we concluded that food processing waste such as molasses, potato starch, or fruit waste can provide carbohydrates for manure acidification, reduce the cost of manure acidification treatment, and an opportunity to recycle 2 agricultural wastes in an environmentally safe manner. Thank you for your attention.